So here in section 5.3, before we actually do solve some equations, I want to look at some basic tips and then also a general strategy here for solving these equations, okay? So make sure you're focusing here and that you try to at least think through this procedure, because we're going to start with some more basic equations, and then over the next couple days we're going to really get into much more advanced equations. And then after we look at different like double angle formulas and the sum and difference formulas, then the equations are going to get even more complicated. So we have to have a good overall strategy here before we can really get to that point. So a couple of things here, just some tips for success when you're dealing with trig equations. First of all, don't forget that you're going to get two answers if you're going from 0 to 2 pi. Unless you have one of those quadrantal angles, it's possible to just get one answer or three answers. But most of the time you're going to get two answers. So remember that all students take calculus and think about those reference angles. Okay? Secondly, check the range of theta that your problem asks you for. You are going to need to look at your directions. Oh, thanks. You need to look at the directions here and make sure that you give the answers that the directions call for. You may have one that actually just sticks to 0 to 2 pi. You may have some that ask for answers in degrees. They'll say 0 to 360 degrees. If it doesn't say, then use radians and go from 0 to 2 pi. Okay? So if you don't see anything else, just assume it's in radians and we're going 0 to 2 pi. And then you'll have other ones, for example, that might go like negative 2 pi to positive 2 pi. Or they might say go from negative pi to pi. Or 0 to 4 pi. Okay, and they want those solutions. So make sure you pay attention to the directions on these problems. I know it's going to be real easy to just kind of get into the habit of always doing it the same way, but you're not going to be asked to necessarily do it always the same way. Okay? So, the other thing is to have this general strategy. I'm giving you one here that I think is really helpful. As you do problems, you may add to it or modify it depending on your, the way you prefer to solve problems and kind of your learning style, so to speak. So, but this is just meant to be a kind of a general framework here. The first thing is when you have an equation that has different trig functions in it, try to get the equation in terms of only one trig function. You'll notice there I say, if you can. Alright, if you can. So, there are going to be occasions when you can't. And we will look at how to handle those. If you have a mixture of trig functions, how are you going to handle that? This is where all those identities and things that we've looked at really come in handy. Okay? So all the simplifying and prove this and do this or that really comes in handy here when you're trying to get everything in terms of one trig function. Okay? Secondly, identify what kind of equation you're dealing with. Okay? Are you dealing with a linear equation, or are you dealing with a quadratic or other polynomial equation? And then think about, how did I solve those types of equations? For example, linear equations, the goal was just get the variable by itself. Well, in this case, if you have a linear trig equation, you're going to get that trig function all by itself. Okay? if you have some kind of a polynomial equation, you're going to say, okay, well, anytime I had a polynomial equation, the first thing I did was get it equal to 0. Well, let's get all the trig functions on one side and get this thing equal to 0. And then maybe I need to factor or something like that, okay? Or if it's a quadratic, for example, and there's no linear term, it's just I've got a sine squared, but there's no term that just has a sine, I could get the sine squared by itself and then square root both sides, or something like that. But you've got to identify what kind of equation you're dealing with so that you know what strategy to use, okay? But the same strategies apply here to the trig functions as they do to just the regular polynomial and linear equations that you've done in the past. And then thirdly, this is the part we've already done. Once you've done all of that, then you'll be able to use those inverse trig functions to actually find the answers that you're looking for. Okay? So, again, that's a really kind of simple three-step process that you can use if you're stuck when looking at an equation. Just walk yourself through this thought process, and it's a good guide to help you get started and get to the point where you can just go with it. Okay? Now, let's do an example, and I do want to talk about one term here that you'll see occasionally. And that is the general solution. So let's think through our thought process, and we're going to solve this equation sine of x minus 1 equals 0. And then we'll also look at the answers at the end here of what we can do with the answers. Okay? So, first of all here, I already only have one trig function to deal with. I only have a sine. So, step 1 is complete. Alright? Everything's in terms of one trig function. So the next thing is this a polynomial style of an equation or a linear style of an equation?
Linear. I want a linear.
Why would it be linear? Okay. Well, there is a degree, but there's no, it's just 1, right? We have a degree of 1. Sine is to the first power. Okay? So, how would you solve any other linear equation? Yeah, just add the 1, get rid of the 2. You're just getting it by itself, right? So, we're going to add 1 and divide by 2, and we end up with sine of x equal to 1/2.
Yeah.
All right? That's what we're talking about. When you had a linear equation, if it were just like a 2y minus 1 equals 0, you just get the y by itself. Well, in this case, you're just going to get the trig function by itself. Okay? Now, you need to think through what your solutions are. Okay? And we're using an inverse trig function. Alright, so x is going to be the inverse sine of 1/2. And this is actually on your unit circle, so we can come up with our answers. What are the answers going to be here? Pi over 6.
150 degrees.
That is 30, and then 150 degrees, which is the same as
7 pi over 6.
That's
5
210.
5 pi over 6.
5 pi over 6. Okay? Sine is a positive 1/2, so we need the first and second quadrants. So we have pi over 6 and 5 pi over 6. Notice here, we're asked for answers from 0 to 2 pi, so our answers should be in radians. Okay? Does everyone get how we got our two answers? Alright. Now, this is one thing that I don't make a huge deal of, alright? But I do want you to be able to do it if need be, okay? And that is giving a general solution. A general solution simply means that you've identified specific solutions from 0 to 2 pi, and then you're also acknowledging that all of the coterminal angles would also be solutions to the equations. Alright? Well, how do we get a coterminal angle? Exactly. Add or subtract 2 pi. So if I'm asked for a general solution for this is what I would do. I'd say it's pi over 6 plus 2 pi n. Okay? And notice the n could be 0, and that'll give me the original pi over 6. It could be a positive, and then I'm adding 2 pi. Or it could be a negative, and that means it'll be subtracting 2 pi. The key is, though, that the n has to be what? An integer, okay? An integer. So, I have pi over 6 plus 2 pi n, or I have the solution 5 pi over 6 plus 2 pi n. And then I would put the condition, I would say where n is an element of the integers. Now, you can write the word integers if you want, but do you remember the symbol?
Yeah, it's kind of like a Z. But
yeah, it's like
two
a
lines
Z,
down the
okay? It's a Z, but it's got 2 diagonal parts to it, okay? So that means n is an element of the integers, okay? So, any questions about that? Alright.
You would do pi over 6 minus 2 pi.
You could, but the fact that n could be any integer, the negatives come in when it's a negative integer. So that'll be subtracting. The fact of the matter is you could put plus or minus, it would still get it. Alright. Any other questions? Alright, let's try another one here. Find all the solutions of sine of x plus radical 2 equals negative sine of x in the interval from 0 to 2 pi. Okay? So here we're given a solution. We're going to give our answers in radians. So let's think about this. We have only one trig function, right? So that part's already set for us. Is this a linear or a polynomial style function? Why?
Because it's square root of 2. Well, no, because x isn't being raised. So
Okay.
it's linear.
Alright, yeah, the signs are not being raised to a power, okay? Now, we could technically have the x's inside be raised to a power, but we'll deal with ones like that later. But yeah, the signs are not being raised to a power, so this is just a linear situation. So, we can solve this the same way we would, y plus square root of 2 equals a negative y. You just get the y's on the same side, and then get y by itself. Alright? So, we're going to get the sine over here. 2 sine of x plus root 2 equals 0. Then we continue to get the sine all by itself. And what does sine of x equal?
Negative radical 2 over 2.
Good, negative radical 2 over 2.
So,
Okay?
5 pi over 4 and 7 pi over
That's right. Okay? Which two quadrants are we in? Third and fourth, because sine is negative. So, x is the inverse sine of negative root 2 over 2. And from our unit circle, we're in the third and fourth quadrants with a reference angle. What's the reference angle here?
Pi over 4.
Pi over 4. So in the third and fourth quadrants, we've got that 5 pi over 4 and 7 pi over 4. Okay? Now, here's kind of a follow-up question. Let's say that instead of 0 to 2 pi, let's say that they asked us to give all the solutions from 0 to pi. What would we say? Yeah, there's no solution. Even though we could find another solution, if we're looking for just from 0 to pi, we would say that there's no solution, because both of these and all of the coterminal angles are going to be outside of that range that they asked for. Okay? So that can happen as well. All right, one last one, and that we have the 3 times the tangent squared of x minus 1 equals 0. So again, there's only one trig function. What kind of equation is this though? It's a quadratic, a polynomial one. So in general, our strategy is to get it equal to 0 and look to factor. In this case, there's no term that just has tangents in it. So how can we solve this one? Since this doesn't really factor.
Pythagorean identities.
We could, but that's going to give us secants, and I'd rather avoid secants if possible. We're more comfortable with tangents.
Wait, we want to get rid of tangents?
No, what I just want to solve it. If I had the equation like 3y squared minus 1 equals 0, how would you solve that?
Just solve
Oh.
Plus y
Yeah.
on both sides and divide by 3.
Okay, so you get y squared equals 1/3,
And
Yeah.
square root.
and then you square root both sides. Yeah, we're going to do the same thing with this one. Since there was no like tangent term in here, there's not a really good way to factor this. So we're going to get this down to where it's tangent squared x equals 1/3, and then that means the tangent of x equals what?
Plus or minus the square root of 1/3.
Yeah, plus or minus square root of 1/3, which equals,
3/3.
good, square root of 3/3. Now that ought to look familiar, because this is from our unit circle as well. Okay? You guys, how could we figure out what angle this is? We should be able to narrow our referenced angle down to 2 different ones. Come on, focus here, guys.
Wouldn't it be
Pi
square root
over
of 3/2 and then something else?
Okay.
Right? Right?
Well, the square root of 3, we see that square root of
Sine-
3 in here,
sine is
so
right,
it's
3/2 and cosine is 1/2.
okay. Either the sine, and this is what you got to work out. Either the sine is square root of 3/2,
Sine.
and cosine is 1/2.
Sine is 1/2 and cosine is square root of 3/2.
Okay. Or yeah, like Alexi said, sine is 1/2, and cosine is √3/2. Either way, sine over cosine has to equal tangent, right? So which one is it?
I think it's the second one.
Yeah.
Where sine is
Second.
1/2 and cosine is right.
Okay. Yeah, if you look at this, the halves cancel
No, it's
out.
right.
This is just going to be √3. Okay? We're missing the over 3 part. With this one, the halves cancel out, and you have 1 over √3, which does equal √3/3. So, good. We want the one where the sine is 1/2 and the cosine is √3/2. So what reference angle is that?
Over 6, 5 or 6.
Oh, that's the root pi over
Pi over
the first
6.
one. Pi over 6.
Pi over 6. That's right. Okay? Pi over 6. So that's the reference angle we're going to use. Okay? And guys, when you're given a tangent one like this, you just have to think it through. Use that quotient identity, sine over cosine. Alright? And use that quotient identity to figure out what your reference angle is. So we don't want that one. We want the pi over 6. Now, here's the thing. You're actually going to get all 4 angles that have the reference angle of pi over 6 because
Plus or minus.
we have the plus or minus. Okay? So here's what we have. X is going to be the inverse tangent of positive √3/3 or the inverse tangent of a negative √3/3. And here is something I want you guys to do. Alright, when you're giving answers like this, I want you to identify which answers are coming from which solution. Okay? Because where is tangent positive?
The first and
Third
third.
and first.
First and third. So what two answers do we get from that positive root 3 over 3?
Pi
Pi
over
over
6.
6 and pi over 6.
7 pi over 6.
Good. Pi over 6 and 7 pi over 6. Alright? Those two are coming from the positive one. The negative one gives us
5 pi over 6.
the other two quadrants, the second and fourth quadrants, okay? So good. 5 pi over 6 and
11 pi over 6.
that's right, 11 pi over 6. Okay? So do make sure it's clear which answers are coming from which solution. That's just part of good communication when you're solving a problem. And also it'll help you just make sure that you're actually thinking it through, which ones are coming from, you know, what do we get when we have a positive tangent? What quadrants are we in when we have a negative tangent? Okay? Alright, so any questions about that? Okay, so let's say you're kind of blanking and you're having trouble figuring out come on. You're having trouble figuring out what your angle is. So you resort, even though you recognize that this is from the unit circle, you resort to using your calculator. Man, how many things do I have open? Here we go. So here's our calculator. But we want exact answers. So we want them in terms of pi. So there's one thing that is helpful for you to be able to do here is give answers in terms of pi, even when you use the calculator to get a decimal answer. Okay? Alright, so here's our calculator. We've got this up. And we got to this point here, and we did that 1/3. We got 1/3, and then we square rooted it. Alright, so here's our square root. And then we're doing the inverse tangent of that answer. Alright, so we hit second tangent. I know I'm in radians, so I'm in the right mode. And I get this for my result. Okay? But I want to write that as something pi over something. I want to write it in terms of pi. Can anyone tell us maybe how we would do that?
How do you put that into radians?
Well, that is in radians. But how would I convert basically the 0.52359877756 into a fraction that has something pi over something?
Like you plug pi with 3.14.
Okay, pi is 3.14. What would I do with that? Let's think about it this way. This, and I'm not going to write the whole thing out, that is some fraction times pi, right?
Yeah.
So how would I get what the fraction is? I would divide by pi. Alright, so my fraction here is going to equal, and by the way, make sure you use the actual pi button. So divided by pi, nope, that's E. Can't see real well. Pi, and I get 0.1666 and so on. Now you may recognize that already as what fraction that is. What fraction is that?
Pi over 6.
There's a 1 in the front.
1 over 6.
It's 1/6, yeah. Now, if you can't recognize it, that's okay, because if you hit math, that first thing is convert to a fraction. So you can hit that and hit enter, and it'll tell you it's 1/6. Okay? So we know that the fraction is 1/6. So now I know that this is pi over 6. Okay? That's an easy way, if you have to use your calculator, to then figure out how to express it in terms of pi. Just divide by pi, figure out what that is as a fraction, and then write your final answer. Okay? So, I just wanted to cover that because it is good to give exact answers. That's really the ideal, is to give those exact answers, not just kind of rounded, it's about this many radians. Okay? So, degrees, you'll just give your answer as a decimal with degrees, and that's fine. But all right. So, any final questions here about solving these ones? Okay. We're starting somewhat basic. All right. We're not getting too complex right now, but tomorrow we're going to up the level of complexity. Work on ones where you have to say factor, and then you're getting multiple options as to what your trig function equals. We'll also look at ones where you're going to have to use identities a lot more, and ones where you're going to have to solve it when there's different trig functions involved. Like you might have a sine in your equation and a tangent. How do you solve the equation when you've got a sine and a tangent? All right, so, and then we're going to look at cases where there's no good way to solve it. You're going to have to just use your graphing utility and find the intersection, like we've done with some of the other more advanced equations. Okay, so the rest of our time, I want you to get started on our practice. Pay attention to directions, however. Notice these first 6, and by the way, all these are from the unit circle, so you don't need your calculators at all. All right, discipline yourself to force yourself to use the unit circle and get that even more ingrained in your head. All right, but the first 6, they want answers from 0 to 360 degrees. Okay, then 13 through 24, answers from 0 to 2 pi radians. Okay. And then the last 4, I gave you a couple here where they are looking for general solutions. Okay, general solutions. So use that plus 2 pi n as you express your answer. Okay? So the rest of the time is yours to start.